Hello, and let us continue our discussion further on entity relationship model. And in the last video, we understood about components of ER model. We began with entity. We understood that entity is any real world object or concept, right? Then we spoke about the properties which define this entity. We call them as attributes. Then we discussed about relationships, like association between entities called as relationship. Then we spoke about primary key, which is an attribute used to uniquely identify. So this is all we discussed. We understood how to represent it in ER model, what is the convention. But for any entity to be a part of a relation, there are some constraint which needs to be fulfilled. We call it as relationship constraints. And in this video, let us discuss few relationship constraints. And let's begin with mapping cardinality. Now, what do you mean by mapping cardinality is, from a entity, there is a particular number of objects which can be related or linked to the other entity. Like, if I say, for example, a person has a head. So one particular person can have one particular head, and one head is associated with one person. So the exactly one, like the number of entities which other entity set can be linked through a certain relationship, we call it as cardinality ratio or mapping cardinality. Now let us discuss the four types of it, and let us begin with one-to-one relationship. So for one-to-one relationship, what happens is, if there are two sets, set A and set B, exactly one from set A will be linked with exactly one from set B, right? This is the case in case of one-to-one relationship. Now, if one, this is the case in case, this is the case for one-to-one mapping cardinality. Now, can you think of example, the one which I said just now? Person has head. Now, similarly, one more example can be a person has one passport. Like the one particular person can have one particular passport, and one passport cannot be associated with multiple people, right? It is associated with only one person. So this is an example of one-to-one cardinality. Let us move ahead and talk about one-to-many. So now what happens in one-to-many is, for example, one student can have many books, but from the other side, if you look, one book can belong to one person only. So from set A, if you look, set A can be associated with many from set B. But from set B, if you see, from set B, it is associated with only one from set A, right? Like this. So this is one-to-many relationship. You can think of many examples. It's better if you think by your own and explore things, because the more you explore, the more you understand, right? Let us move ahead and talk about many-to-one relationship. Now, the example to consider here is, many students are enrolled in one class. So if you look from students' point of view, many students are part of one class. But if you see from class view, one class contains many students. So object from set A, entities from set A can, many entities from set A can be related with only one entity of set B, but one entity from set B can be related with many entities. So this is how one-to-many relationship looks like. Okay. So let us move ahead and talk about many-to-many relationship. So in many-to-many relationship, both sides, it is multiple entities enrolled in that relationship. Like many students are enrolled in many courses. Now what happens is, if we say this is set A and this is set B, so multiple from set A are related with multiple from set B, and same is the case the other way, right? So this is how many-to-many relationship works. Let us move ahead and talk more about other constraints. Let us talk about participation constraints. So for this particular example, like customer borrows loans. So there are some customers in bank. Now a customer can may and may not borrow loan, right? Now let us discuss about other constraints, which are, let's talk about participation constraint. Now in participation constraint, Let us take one example, that is customer borrows loans. Now, if I say customer for any loan, like try to imagine the situation. All loans are associated with one or the other customer, right? It is not possible for a loan to independently exist and be there without any customer. It is always there, right? All loans are associated with one or the other customer. So this is known as total participation, where we represent it with the double line like this, where all these loans participate in this relationship. But for the customer side, it is not necessary that all customers take loan. Few customers may and few customers may not. So when a partial entities from this set participate in the relationship, we represent it with a thin line, a single line, and we call it as partial participation. But whereas when all the entities are involved in this relationship, we call it as total participation, right? So if it is clear, let us move and take one example of partial participation. So it is like person works at factory. If we take person, now what happens is a person may or may not work at factory. So this is a partial participation. Like it is not necessary for all people to work at uh, uh, a factory, and it is not possible for it is not necessary that all factories have some percent working. So this is the case of partial participation. So I think this is it for the video, and let us discuss about more features of AR model in the next upcoming videos, and we'll be trying drawing few examples, real world problems. So that's it. Keep learning, keep practicing, and let's meet in another.